Oh my goodness, I did all that talking and none of it recorded. All right, ladies and gentlemen, let me back that up. You just watched a bunch of silence, and I'm really sorry. Okay, make sure you've turned in your homework. There's no quiz today. We're doing page 22 to 23. You're doing every third problem, so anything divisible by 3. So 12, 15, 18, so on and so forth. I'm really sorry about the no volume. All right, so we're going to write an algebraic expression. And so you're currently writing your notes. 7 fewer than a number. And what you're doing right now is you're writing that in English. Yes, I know. And we're going to write that in mathese in a minute. That's what I call algebra. I call it mathese, and that's what you're going to do. So as you're writing in my math, 7 fewer than a number. What is that going to look like? You should be saying to yourself, Self, what does that look like? 7 fewer than a number. Okay, because of the word fewer, you should recognize with the word fewer, that's going to mean, oh, I need to start with whatever the number is, and you can pick any letter of the alphabet for your number. I'm going to use K. So any letter, and it's 7 fewer. What's fewer? Fewer is subtraction. So it would be K minus 7, or N minus 7, or X minus 7, whatever makes you happy. But fewer tells you that you're going to have to throw the number on the back side of what's going on. Now, we're not going to, of course, have your turns today, so I'll do it again. 2 times the sum of A and B. So this time I'm telling you what letters to use. So times is multiplication. Sum is addition. So we should have 2 times the sum of A and B. So it would look like that in algebra. So in math language, it's 2 parentheses A plus B close parenthesis. All right. Let's model it using words now. So you start with $20 and save $6 each week. What algebraic expression models the total amount you saved? Okay, so we know we're going to start out with $20 in my account. So in my bank, I have $20. And I'm going to save. What does save mean to you? Does save mean you're going to add money to your account, or does it mean you're going to subtract money from your account? That's right, save means addition. So I'm going to add $6 each week. Do I know how many weeks I'm going to do this for? No, I don't. So that's going to be 6W. 6 times however many weeks I save. If I save for 10 weeks, that's 6 times 10 plus 20. If I save for 100 weeks, that's 6 times 100 plus 20. All right, down here at the bottom, you have $150 in your account, but you're going to spend $2 each day. Spending, is that adding or subtracting? So we're going to subtract $2 each day. Do I know how many days I'm going to do this? Sure don't. So that's 2 times D. So 150 minus 2D. All right, what is the value of the expression for the given values of the variable? So this is just what I call good old-fashioned plug and chug. I'm going to take where the A is, and I'm going to plug in the -4. I'm going to take where the B is, and I'm going to plug in the 5. And then I'm going to use my order of operations to complete this problem. So -4 plus 4 is 0. 0, so this becomes 7 times 0, plus 3 times 5 is 15, minus 8. Well, 0 times anything is 0. So my answer is just a grand and glorious 7. Same thing happens down below. I'm going to plug in a 1 for the x, and I'm going to plug in a 1/2 for the y. I'm going to do the voodoo that I do. So when I square 1/2, because the order of operations says I need to square, I need to do my exponents first, that's 1/4. Oh no, I don't have common denominators. What is a common denominator of 2 and 4? Well, it's 4. So I'm going to multiply the top and the bottom of the first fraction by 2. And then I'm going to take and I'm going to add these together, and I get 3/4 as my answer. See, aren't you glad that it's not your turn and you had to do this yourself? All right, here we go. We're on page 5 of 7. Let's do this nasty looking guy. So I have 2 times the quantity of, well, I'm going to plug 6 in for the x. I'm going to plug a -3 in for the y. That's all divided by 3. Make note, ladies and gentlemen, right here. I put parentheses around that. because it says y squared. And if y is negative 3, I need to square the negative 3. I'm not squaring just 3, I'm squaring negative 3. So now I have 2 times the quantity of 36 minus 9 over 3, which is 2 times the quantity of, well, 36 minus 9 is 27, divided by 3. And since I'm standing here at the board and I do not have a calculator, I note that 3 goes into 27 9 times, so my answer is 18. Save myself some times. I could have multiplied 2 times 27 and divided that big answer by 3, but that way I made a shortcut for myself. All right, here we go. In a football, a touchdown, T, is worth 6 points. An extra point, K, is 1 point. And a field goal, F, is 3 points. What algebraic expression models the total number of points that the football team scores in a game, assuming that each scoring play is one of the 3 given types? So, ladies and gentlemen, it says give me an expression. I haven't even read any further. I stopped. I had a question mark right here. I stopped. It says to myself, I need to write an expression. So, I know that a touchdown is 6 points, so that's 6T. Plus, the extra kickoff point is K, which is 1, so it would be 1 times K, but I'm not going to put the 1 here. You can, won't matter. And then a field goal is 3 points, so that's 3F. This, ladies and gentlemen, is the expression. A lot of times people will forget to write me the expressions on a test, and that is some major point loss. If it asks for the expression, you must write the expression. So now I finished this one. Boom, that part's done. So suppose a football team scores 3 touchdowns, 2 kickoffs, and 4 field goals. So how many points did the team score? So here's another question mark. So I need to answer that. So we are going to plug this in. So I have 6 times, it said 3 touchdowns, plus I have 2 kickoffs, which are 1 point each, so I have 3 of those. And then we are going to have, formula says 3 times how many? We had 4. Notice I used 2 different ways to write multiplication just to demonstrate that we have, oh, ladies and gentlemen, I goofed. This is not 3. Mrs. Miller did not read correctly. This is a 2. Sorry. All right, so 6 times 3 is 18, plus 2 plus 3 times 4 is 12. 18 plus 2 is 20, plus 12 is 32. Now, if you leave me 32, you just lost a half point. This is a word problem. It has a label. These are points. So there are 32 points we scored in that game. So if this were a test question, you would have had points up here for the expression, and then this part right here, and you would have had points right here for getting the answer correct there at the end. So did we take care of both question marks? Sure we did. Good to go. All right. Last page of notes. So simplifying algebraic expressions. That just means combining like terms. So I use this right here, CLT, for combining like terms because it takes too long to write it all the time. So CLT. So I see that I have a 7x squared here and a minus 4x. So 7x squared minus 4x squared is 3x squared. I see that I have a 3y squared plus a 2y squared, so I have plus 5y squared. Since these 2 terms are not alike, we're finished. Now down here on the your turn problem, I notice that I have a minus sign outside of a parenthesis, which says I need to distribute that minus to everything inside the parenthesis. So this becomes negative 3k minus m plus, now I'm going to so I distributed this, now I'm going to distribute the 2. And that's going to become plus 2k minus 8m. Now I'm going to combine my like terms. So I have a negative 3k and a plus 2k, which is a negative k. I have a minus m and a minus 8m, which means I have a minus 9m. These are not like terms, so I will not combine them. All right, so ladies and gentlemen, that ends your notes for today. Hope that went well for you. As I said, that was all stuff you've learned but past, just refreshing your memory. And here we go. Let's finish up on the last thing. There is your assignment that is due tomorrow. I will answer questions in class if we get stuck. All All right, have a great day, and I will see you tomorrow.